Today we're going to be talking about the power of zero. So we're going to start with an investigation, and we're going to try to answer the question, what happens when you have an exponent of zero? So we're going to do a little investigation. We're going to take a look at two examples, and you will notice neither of those examples have a power of zero in them, but be patient. We're going to take that question and we're going to try to do it two different ways. We're going to do it once where we use exponent laws, and then once where we actually work it out and see what it equals. So I'm going to start with 5 to the power of 3 divided by 5 to the power of 3. So if I use exponent laws, we have learned so far that when you are dividing two things with the same base, you leave the base the same and subtract the exponents. So 5 to the power of 3 divided by 5 to the power of 3 would be 5 to the power of 3 minus 3, or 5 to the power of 0. There's that power of 0 we were talking about. If I try to take the question and do it with evaluating, I'm actually going to work out what 5 to the power of 3 is and then divide it by what 5 to the power of 3 is. So 5 to the power of 3 is 125. You can either use your exponent button or you can do 5 times 5 times 5. So I get 125 divided by, and then 5 to the power of 3 is 125. So 125 divided by 125 equals 1. So this just equals 1. We're going to take a look at our next example. So I have 2 to the power of 10 divided by 2 to the power of 10. Once again, no exponent of 0 in sight. So I'm going to try it with exponent laws first. They have the same base, so we leave the base the same and subtract our exponents. So this is going to be 2 to the power of 10 minus 10. 10 minus 10 is 0. So there's that power of 0. We get 2 to the power of 0. Our second way of doing it, we're going to try evaluating. So I'm going to work out 2 to the power of 10, which is 1024. So this equals 1024 divided by 2 to the power of 10, which is 1024, same number. So if I take 1024 and divide it by 1024, I once again just get 1. So I'm going to ask you to put on your thinking cap and take a minute. I want you to look at 5 to the power of 0 and 2 to the power of 0. And then I want you to look at what we got they were equal to when we evaluated. And I want you to see if you notice anything special. I'm hoping that you noticed what I noticed, which is that they both equaled 1. So anything to the power of 0, with the exception of 0, which is a little bit weird, equals 1. So it says any non-zero base to the power of 0 equals 1. So we're going to try a couple of examples of this. So we're going to start with evaluating 19 to the power of 0. So I am not going to use my calculator for this. We just learned that anything that's not a 0 to the power of 0 equals 1. So 19 to the power of 0 equals 1. How about x to the power of 0? Well, anything to the power of 0 equals 1, so x to the power of 0 equals 1. Now you'll notice the next two examples look very similar. The only difference is one of them has a bracket and one of them does not. So if I look at the first one, I have 6a in a bracket to the power of 0. That power of 0 is on the bracket, which means the whole thing is going to just become a 1. But the next one, when I have 6a to the power of 0, that power of 0 is only on the a. So here, when there was a bracket, the 0 was on the bracket, so everything inside the bracket just became a 1. But here, the only thing on the power of 0 that has the power of 0 is the a. So that 6 is just sitting there waiting, and then the a to the 0 becomes a 1. These are being multiplied, so this is 6 times 1, and 6 times 1 equals 6. So the trickiest thing about working with the power of 0 is not what it equals to, because it does just equal 1. It's knowing what exactly is to the power of 0. Is it the whole thing to the power of 0? Is it just one part to the power of 0? Who owns that power of 0? So we're going to take a look at 4 more examples. These ones say simplify, which means their answers probably aren't just numbers, but we'll have to wait and see. So this one says 4a to the 0 b. So I do notice that there is a power of 0. But the first thing I have to figure out is who owns that power of 0. That power of 0 is right next to the a. So the only thing here to the power of 0 is actually just the a. So the 4 is not to the power of 0. The b is not to the power of 0. It's only the a. So a to the power of 0 is 1. So this is going to be 4 times 1 times b. So 4 times 1 is 4, and 4 times b is just 4b. So that equals 4b. If I take a look at the next one, I have xy to the 0 plus, in a bracket, xy to the power of 0. So if I take a look at the first part, xy to the power of 0, that power of 0 belongs to the y. So the x does not change, it just stays an x. The y to the 0 becomes a 1. And then plus. Now this time that power of 0 is on the bracket, which means the whole thing is to the power of 0. So that whole thing just becomes a 1. So I have x times 1 plus 1. Now I can't add 1 and 1 because we're multiplying and you have to follow your BEDMAS rules always. So 1 times x is just 1x, or x, and then plus 1. X and 1 are not like terms, so I cannot add them together. So it's just x plus 1, or if you want to write the 1 in, 1x plus 1. If we take a look at the next one, I have 7 to the power of 0, x, y to the power of 0. So I have 2 different powers of 0. The first one here is just on the 7, and then the second one is only on the y. So that means 7 to the power of 0 is going to equal 1. The x is still just going to sit there and wait its turn, and then y to the power of 0 equals 1. 1 times x is 1x, and then times 1 is still 1x, or I'm just going to write x, but you could write 1x. All right, our last question, I have 5 times x plus 3y in a bracket to the power of 0. So this power of 0 is on the bracket, which means this whole bracket is going to turn into a 1. So the 5 is going to stay there. It doesn't change. So we're going to have 5 times 1. And 5 times 1 is just 5. And that's what you need to know about the power of 0.